Hello everyone. Today in this video I'm going to continue explaining section 3 of chapter 7, which talks about percent composition. So there are basically two formulas that we can apply, and as I told you in your SAT test, they're only going to test your skill in in every question they're only testing you in one skill. So basically we have this formula in front of you that says that if you want to find the percent element in compound, all you need to do is that you divide the mass of the element in sample of compound by the mass of the sample of compound multiplied by 100. So what does that mean? If I want to find the percent of, and this is actually one of two formulas. So you can apply one of two formulas. I'm going to show you the second one after we explain this one. So the percentage of the element, let's say we have a compound, let's say water, H2O. Okay, so if you're given the grams of hydrogen and the grams of water, just divide those by each other and multiply it by 100, you get the percentage of that element in that compound. Now, remember that you have to always assume that you have, okay, 100% of that compound. So whatever percentage you find or you get for the first element, if it's made of two elements, that compound is made of two elements like water, hydrogen and oxygen. If you find the percentage of hydrogen, all you need to do is just subtract it from 100, and then you get the percentage of the second element. But if you have more than two elements, that means that you have to go, you have to have the mass of at least two of these elements to find the third one. Okay, so it's simple and it's direct. Just divide mass of that element per mole of that compound by the mass of the compound given to you. The second formula that we can apply is if you have the molar mass of that compound, okay, so you have the molar mass, and you have the mass of the element in 1 mole of compound. Okay, so let's go back to our example of water. So let's say we have 5 grams per mole water of hydrogen, let's say. All you need to do is that you just divide it by the molar mass of hydrogen, of water, sorry, which is 18. Okay, molar mass of water is 18. If you if you don't know how we got 18, all you need to do is just multiply 2 times 1.02 for hydrogen, and then 1.01 for hydrogen, and then just add that to that because it's H2O. So we have 1 oxygen, which is 16. So 16 plus 2 is 18. So just divide that mass of hydrogen that you have, divide that by 18, okay? And then multiply it by 100 over here, and then you get the percent of that element in the compound. Okay, so over here, I have an example. For example, what is the mass composition of carbon in 33 grams of ibuprofen, which is C13H18O2, given the molar mass of ibuprofen as 206.31 grams per mole? Okay, so here you have the mass of carbon. And over here, I just listed that. Okay, so step number 1, you have to find the mass of carbon. Step number 2, apply the rule or the formula, either one, this or that. Okay, there's a note that I wrote over here. Subscripts are moles of that element. What does that mean? It means, for example, if I have this ibuprofen compound, that means that I have 13 moles of carbon 18 moles of hydrogen and 2 moles of oxygen, of O2. So you need these for calculations, especially if you're trying to find the mass of a certain element given for a certain mass of compound. So let's apply that. Step number 1. Okay, so remember, what is given in the question is just the mass of the compound. I have the mass of the compound and the molar mass. I have the mass, which is 33 grams of ibuprofen, and I have the molar mass of it. Now, how did we calculate this molar mass? It's just 13 times 12 plus 18 times 1.01 plus 2 times 16. You get that number over here. Okay, so let's apply this formula right over here. This is what we're applying. So basically what's given, okay, so I have here from the compound, I know that I have 13 moles of carbon. And we know that the molar mass for carbon is 12.01 grams per mole. And you get this from the periodic table. Remember, it's the big number, not the small one. It's the bigger number. Or average atomic mass. That's what we call average atomic mass. And it's the molar mass that we use in conversions. Okay, so basically, how do I work this? So if I write, I have 13 moles of carbon. I have 13 moles of carbon per mole ibuprofen. The IBU here stands for ibuprofen. So you can notice that I'm trying to find the mass of carbon. I'm trying to find mass of carbon. So that means grams of carbon. So you can tell that you need to cancel moles of carbon. Now, where do I find this amount? How can I cancel it? From the average atomic mass of carbon, which represents the molar mass of carbon. So I write that. Now, moles of carbon cancel with moles of carbon. Great, now I got grams of carbon, but I'm still stuck with what? I still need to get rid of 1 mole of ibuprofen. Mole ibuprofen, that's the unit that I need to cancel. So it can only be canceled if I know the amount of moles of ibuprofen. And we do know that. And we can find that it's equal to it's 0.16 moles. Now, how did I find that? We found it from grams and molar mass. Grams and molar mass. Do you remember when we explained the triangle? Okay, so triangle number 1, remember, we said that it's mass, molar mass, and moles. So mass is given, which is 33 grams. Molar mass is given, which is 206.31. And remember, this line is what? Division. So moles of ibuprofen is equal to mass divided by molar mass, which is 206.31. And then you're going to get moles ibuprofen. Okay, so we're going to plug that over here, and then we just cancel these two together and we get 25 grams of carbon. Okay, so now I found the mass of carbon. Now step number 2 is percentage of carbon is equal to mass of carbon, 25 grams of carbon per mole of ibuprofen. Divide that by the molar mass of ibuprofen, and that gives you 12.12%. Thank you for watching.